All right, good afternoon, everyone. My name is Qiang Li. I'm a pavement solution engineer with CEMEX, and we produce concrete, cement, and aggregates. And we also provide technical support to engineer firms, government agencies, and contractors. And concrete is one of the most popular construction materials, and cement is one of the major components in the fresh concrete. But in the production of the cement, it generates a lot of carbon dioxide. It's not very environmental friendly. So what we can do is that to making concrete more sustainable, we can using some waste material in the concrete mix and replace the cement to making concrete more sustainable. So those material, we call it supplementary cementitious material. Historically, fly ash has been widely used as a supplementary cementitious material. It's low cost, easy to use, and readily available. But things are changing because fly ash is the byproduct of using coal to generate electricity. Because the lower price of natural gas, more and more power plants using natural gas instead of coal, and more people using solar or wind to generate electricity. So they're using less coal, less fly ash will generate during the process. So that's created a very tight market. So in the past year, we have been working on bringing a new material called Slag into the market. And today I'm going to talking about what is the supplementary cementitious material and how Slag fit in this picture. This is the outline. So first I was talking about what is the supplementary cementitious material and why we're using those materials in our concrete mix. The second is that what is the slag and why we need slag in your mix. And finally, we're talking about when you're using slag in your concrete mix, how it's going to change the property of your concrete. The first question will be, what are the supplementary cementitious material? So actually, those materials just you adding to your concrete mix and help you concrete gain strength and getting harder. So concrete can getting hardened through two activities. One is called hydraulic activity, the other is called pozzolanic activity. So what is the hydraulic activity? It's the chemical reaction between cement and water. So during this process, it formed two major chemicals. The first is called calcium silicate hydrates. It's a good stuff. It's helping concrete to gain strength and ensure the long-term performance of the concrete. And the other chemical formed during this reaction is called CH, calcium hydroxide. It provides a little bit early strength for the concrete, but in the long term, it tends to create a lot of durability problems, such as ASR, alkali silicate reactions, and reduce the durability of the concrete. So what we can do is that we can add in a supplementary cementitious material in the mix. So those materials are going to react with the bad stuff, the CH, and form more good stuff, CSH, calcium silicate hydroxide. So during this process, it's going to densify the concrete and increase the durability of the concrete. So the most commonly using ICM, supplementary cementitious material, are fly ash, slag, silicon film. And those been available on the market for a very long time. And so what's the difference between fly ash, slag, natural porcelains, porcelain cement, and silicon film? So from this plot, you can ensure there's only three components. First is the calcium oxide, and aluminum oxide, and silicate oxide. So actually, all those materials are made up of those three components. It's just different combination of those three components. As you can see, porcelain cement is right here. It has more calcium in it, and fly ash and natural porcelains and silica film has more silicate in their compound. So what we really need is the silicate. So the silicate can react with the bad stuff, the CH calcium hydroxide, and forming the good stuff, helping concrete to gain more strength. So as you can see, slag is more close to the conventional Portland cement concrete. It not has that much silicate as fly ash and natural Portland, but it does have like 20 to 30% of silicate. So it can help. It can help on reduce the CH and forming more good stuff in your concrete mix. And what you need to do when you're using slag instead of fly ash is you need to adding more slag to your concrete mix compared to fly ash to ensure the same amount of chemical reaction take place in your concrete mix. So what the SCM does in your concrete mix, it can help, as I mentioned before, in terms of the chemical reactions. It can react with the CH and forming more CSH, the good stuff. So during the whole process, by more chemical reaction taking place in your concrete mix, it actually densifies the concrete. So it increases the long-term strength of your concrete. At the same time, by densified concrete, you reduce the permeability of the concrete. So it's harder for chloride, sulfate, and water penetrate into your concrete. It makes it harder for those materials getting into the steel. So it's going to reduce corrosion of your steel and making the steel and concrete lasting longer. And the plot on the right side showing the absorption over the times. And for 3 different mix, the conventional concrete, with 15% fly ash replacement and 35% of slag replacement. As you can see, when you're adding fly ash or slag, you can significantly reduce the absorption, which means you reduce the permeability and increase the chloride resistance, increasing the sulfate resistance, and also help you on freeze and thaw resistance. And for those of you not familiar with alkali-silica reactivity, it's the reaction between the alkali in the cement and the silicate in the aggregates. So when those 2 materials met in concrete mix, they're going to react with each other, and the concrete tends to grow. But since in the concrete, there's no place for them to grow, no space for them to grow, so it tends to cracking and fall apart. So if we're adding supplementary material in there, it's going to react with the alkali in the cement paste and forming more good stuff, CSH, during the hydration process. So it's going to significantly help you to mitigating the ASR, the alkali-silicate reactivity. But if you're asking people why are you using fly ash, slag, historically, they're going to tell you because they are cheap. Because usually the fly ash or slag are cheaper compared to cement. So if you're using those materials in your concrete mix, but now we know the real reason we're using those materials are to help concrete getting higher durability, increase the long-term performance. But at the same time, you do getting some cost saving by using those materials. So what is happening on the fly ash market? As you can see on the plots, the natural gas is on the incline because of the price of the natural gas getting lower, and more power plants start using natural gas instead of coal. And fly ash is the byproduct of using coal to generate electricity. So if the power plant using less coal, less fly ash is going to be generated during the process. At the same time, you see the figure on the lower right side, the fly ash production almost cutting in half within past 11 years. So at the same time, more power was generated using solar, wind, and other resources. So a lot of power plants using coal was shutting down in the past 5 or 10 years. At the same time, based on our experience, you're also getting a lot of variabilities when you're using fly ash in your project. If they're coming from different power plants, they will have different properties, and you have to run a lot of lab testing to confirm they meet your specifications using those materials. And at the same time, the need for the supplementary cementitious material are increasing in the past couple of years. So more and more people realize those materials can help you concrete to getting long-term performance and increase their durability, reduce the permeability. So more and more people want to adding those materials in their concrete. So those specifically speak about California. There's no power plant produce fly ash in California. And there are two major suppliers for fly ash, and all the power plants are located in the other states. And all the fly ash we're using in the project in California is import fly ash from the other states. At the same time, the folks in those states are also using the fly ash, and their needs are increasing. So you have to consider in the long-term run, if fly ash is not available, you have to figure out using some other materials. So if you predict what next 10 years going to look like, those are showing the resources for fly ash in the next 5 years and 10 years. As you can see, more and more power plant was shutting down, and all using more natural gas in the power plant. You may not have fly ash available in next 10 or 15 years. And this create a very tight market. So how can they fill those gaps? We think that we can fill those gaps using a material called slag. So what is the slag? It's a byproduct of steel production. So during the steel production, there's a process called fast quenching. And during the fast rapid quenching process, the slag was separated from the melting iron. So it's kind of like glass type sand material, and we grind it to a white powder. And the slag particles are usually finer than the cement particles, and it can react similarly to the Portland cement with water. And the good thing is that because this is a byproduct, so it's very environmental friendly. It's a waste material we're using in our construction. And another thing is that it's a white powder. If you're using this in your concrete mix, because cement was gray, dark gray color, so if you're using slag to replace certain percent of your slag, it's going to result in a lighter color in your finished concrete. So it's going to reflect more lights and reduce the urban heat island effect. And slag has been widely using for different projects. So there are a lot of specification available for you to specify the slag in your future projects. So as ASTM, AASHTO, ACI, and Caltrans also have specs regarding the slag. So based on the ASTM and AASHTO standards, there are 3 different grades of slag, depends on the strength of the mortar cubes. So in California, we are import and selling we call SAM slag all across California. So it's already approved by Caltrans, and based on the ASTM and AASHTO standard, it's grade 120 slag. Here's some examples like how slag can help you on your concrete mix. So as I mentioned, slag particles are finer and smoother compared to cement particles. So when you're adding those things to your concrete mix, it's going to increase the workability of your concrete mix, which help you to more easier to finish and more easier to place the concrete. And at the same time, when you increase the slag, as you can see, some testing results at the bottom, absorption over the time for 4 different types of chemicals, and those are the conventional Portland cement concretes. Those are the concrete with 35% slag replacement. As you can see, it can reduce the absorption, which means reduce the permeability of those materials, and that's going to increase your durability of your concrete. At the same time, when you're adding slag like more than 60% in your concrete mix, it's going to significantly reduce the hydration heat. So when you pour a large amount of concrete, you can using a lot of slag in your cement to reduce the thermal stress. At the same time, as I mentioned in the previous slides, it's a white powder, so it's going to make your concrete lighter, reflect more light, and help on the urban heat island effect. And it can also react with the alkali in your cement and reduce the ASR attack. And by more reaction taking place in your concrete mix, it densifies concrete and helping you on the sulfate resistance and also increasing the freeze and thaw resistance. And here's another small examples that how Slag is going to change your concrete properties, either fresh concrete and hardened concrete. So one thing I have to mention is it does reduce the hydration heat, so you can using up to even 80% replacement rate in your concrete mix when you pour a large amount of concrete. And also is by taking more chemical reaction taking place in your concrete, it's actually slow down the setting time a little bit. So you may getting a little bit early strength reduction, but in the long run, the long-term strength you're going to getting higher long-term strength using slag in your concrete mix. And for some other property, we think that it's about even compared to the conventional concrete. And we do run some library testing in our local lab done in San Diego. So we replace, we're using no slag, 25% of slag and 50% of slag. And those are the compressive strengths over different curing times. For 7 days, it's about even. And we also have some 1 day and 3 days results showing that the strengths are a little bit lower compared to the conventional concrete mix. But in the long-term strengths as 28 days and 56 days, you can see the mix-based slag replacements showing higher compressive strengths compared to the conventional material. And also, one thing you have to pay attention is if you're adding slag in your concrete mix, it does increase the workability of your concrete, which means it's increase the slump of your concrete. So as you can see, when 25% and 50% for replacements, you're getting much higher slump for your concrete mix. Here's some testing results. We are trying to compare 25% slag replacement versus 15% fly ash replacement. So those plots showing the compressive strength over various water cement ratio. And the solid line is 7 days strength, and the dashed line is 28 days break. As you can see, there's no, we didn't see too much difference in terms of strength than using 25% and slag and 15% of fly ash. So which means the 25% replacement of slag can result in similar compressive strength by 15% of fly ash replacement. So slag has been widely used on various projects. Here are some examples. This is residential tower buildings done in San Jose. It's a 28-story residential towers, and they using 25% slag replacement in their foundation. So far, they have cost 68,000 cubic yard concrete, and those projects going to complete in 2021. And it's a very high-profile projects, very important, and slag playing a key role in the success of those projects. Here's another project. I think people down in Bay Area may must aware this project because the successful of Golden State Warrior and their recently success in playing basketball. Even they are not that good this year, but they probably getting better next year. And so they are building a new arena, and for this project, they are using 25% slag and 25% fly ash in their piles and walls and beams. Again, it's very high profile projects, and they feel comfortable to using slag in their projects. Here's another typical housing project done in UC San Francisco. They're using 30% slag replacement and 20% fly ash replacements in their projects. It's a typical housing projects and where slag can make good fit in. If you're not familiar with Prodigies, they are one of the largest industry developers, and those are two projects. Two tiered-up projects. For both projects, they're using slag. In Tracy, they're using 15% slag replacements in their tiered-up panels, and in Pleasanton, they're also using 15% slag replacement in their slag bonded grade. Again, those very typical tiered-up projects, and they feel very comfortable using slag in their projects. So one thing I have to mention to all the contractors is that curing is very important for the concrete mix with high percentage of slag, because it's not only the hydraulic reactivity, it also has pozzolanic reactivity take place in your concrete mix. So it takes longer time compared to conventional concrete. So both of the reaction need water to ensure those chemical reaction take place. So you have to keep moisture in your concrete mix. So what you have to do is you have to put right amount of curing compound on your concrete mix at the right time. So what you recommend is that after you finish your concrete, you immediately put on the curing compound at the right rate to keep moisture in your concrete mix to ensure you gain the long-term strength. As I mentioned before, by having more chemical reaction taking place in your concrete mix, it does slow down the setting a little bit. So if you're adding high percentage of a slag replacement, it's going to slow down the hydration process. But it also depends on the ambient temperature, the replacement rate. So when you're doing construction at very high replacement rate and at very low temperature, we usually recommend them to adding some accelerators in your concrete mix to ensure you have time to cutting the joint and make sure that the concrete getting hardened on the right time. Based on our experience, the admixture, the effect of admixture is similar to what you're going to expect from the conventional concrete. So, but since we using slag, you're going to densify the concrete, so you may need a little bit more doses for the air entraining agent. And some people have experience to because the slag going to increase the durability, the workability of your concrete, resulting in higher slump. So you may need less doses for water reducer or higher water reducer. And same time, when you add very low temperature, high replacement rate for slag, you may be very careful about using the retarder because you already slow down the hydration process by using slag. If you're adding retarder, it's going to amplify the effect of retarding. So you may need to run some library testing to figure it out, help you figure it out. And finally, is the picture color comparison between the slag and the Portland cement. As you can see, it's the white powder. So
I'm sorry, by low temperature, what would be considered low temperature?
Because at low temperature, when you're adding slag in your mix, it slows down the setting time.
What is low temperature?
Low temperature? Yeah, like we're talking about like lower than 10 degrees C.
Oh.
Mm. So since slag has lighting color, so if you're adding those materials in your concrete mix, it's resulting in a lighting color of your concrete. So it's going to reflect more lights and help on the urban heat island effect, reduce the urban heat island effect. Here's some specification available for you to use to specify the slag. at the same time, Slag Cement Association develop a table for you to use to figure out, like, at different applications, how the typical percentage you need for different applications. So as you can see, for ASR mitigation on mass concrete, you may use up to 70% or 80% of your replacement rate. That's pretty much complete my presentation. And any questions?
What's the cost comparison of slag versus fly ash? Like, is it?
Let's mention. Yeah, I mentioned before. It's just the price range. It may vary at different region, but typically you're talking about for cement, it's about 110 to 100, maybe 130 per ton, and for fly ash is cheaper than slag. But problem is that fly ash may not available for some project. It's very hard for you to find fly ash. But slag does cheaper than cement. So if you're using, and another thing is that for slag. For fly ash, you may replace highs maybe 50%, but for slag, you can replace like 70 to 80%, because slag is more similar to cement, and you can adding more percentage and reduce the cost of your concrete mix.
I have a bunch of questions.
Sure.
So is there a possibility of using 100% fly ash or slag and completely remove or replace this Portland cement?
It's possible because there's similar reaction in, but we haven't do any lab testing. Just try to use only slag. But I think there's some possibility you can only using slag.
So I guess I've seen there is a startup company in Canada. They started using 100%, or they call it no cement concrete, that they're using 100% fly ash or slag, and they are using a specific type of admixture to help with the carbonation process of the hydration process or the chemical reaction. So that might affect any. Do you think that would affect anything related to radius strengths or any other properties?
Yeah, as you can see from these plots, there's the fly ash, and so there's the Portland cement. So as you can see, slag is more close to Portland cement, and he only has like 20% silicon phase. So it can react with water similar to Portland cement, and fly ash may having too much silicate in the material. You may not have enough calcium to gain the strength, but for slag, I think the strength would be similar to, I mean, not early strength, maybe long-term strength would be similar to conventional concrete. Yep.
So, yeah,
Do you have to know the shelf life of slag and fly ash? Like, how long can you use the product for? Before, like, having to replace it?
You mean the design life for your material? For concrete, it's probably lasting more than 100 years. No matter it's using fly ash or slag, all of those concrete material, if you're doing good maintenance, it's gonna lasting more than 100 years.
So this means that fly ash is more susceptible to ASR compared to slag?
Yeah, for ASR, you need silicates to help you to mitigate the ASR.
So it's slag.
Yeah, slag can help you on mitigating, I think, because it has 20 to 30% of silicate in there to help you mitigating the ASR reaction.
Do you have any test results that shows the effect of slag or fly ash on shrinkage or minor cracks or drying shrinkage cracks?
We haven't done too much lab testing, but based on our experience, like they don't have too much effect on the shrinkage. As I mentioned, I think I mentioned this on the slide. So for shrinkage, we usually drying shrinkage, we usually thinking it's about even with conventional concrete. Not too much effect to reduce the shrinkage.
Questions? What about pavement applications? So this is a pavement class, and I guess.
Yeah, for pavement application, one of the good things using slag because, as I mentioned, it increase durability. So it's gonna make your concrete like very easy to finish. You're gonna increase the uniformities of bench by bench. So we have been using those for several projects in Illinois and Michigan, and the contract over there because over there it has a lot of slag. So in California, we import the slag for over there because they have a lot of steel factors. So they have been routinely using slag in their paving projects. So they don't even know how to pave without slag because they're having so much on the workabilities. As you can see here, like 25%, 50%, you slump value from 3 inch to 6 inch makes much easier for you to finish. You have smooth surface when you're paving, much easier using slag.
What about the precast sections?
I haven't been involved too much precast projects, but I think it should be lower. At least you lower your cost by using slag, and the curing condition was much better compared to on-site cost ready-mix material. So you probably 100% cash out the long-term strength gain.
Right.
Mm.
Any other questions from the pavement class? This is the time to show off your pavement knowledge. All right. If no questions, then thank you.
Thank you. Yeah, sure.
I was wondering if the curing is also the same as just regular concrete using fly ash or the Portland cement.
So as a concrete contractor, you have to be very disciplined on the curing process. So no matter using fly ash, slag, and you have to make sure that there's moisture in your concrete to ensure those chemical reactions take place. As you can see here, so concrete gains strength through hydraulic activity and pozzolanic activity. So all those two chemical reactions need water. So you have to make sure the water is in there to have those two reactions take place. So this is the conventional concrete. They have polycement react with water, and those are the supplementary cementitious material react with water and the bad stuff, and to reduce the CH and form more CSH. So both of those reactions need water. So no matter what, you need keep the moisture in your concrete mix during the curing process.
So either way, it's going to be like
In the industry right now, we usually like after you cast the concrete, you immediately, as long as they have enough strength, you put the curing compound on top of it to prevent losing the moisture. Yeah.
But I just wanted to know the flowability of the concrete. Like even after that, when we are going for a bigger pavement project, will it need the same test as the conventional concrete? For example, vibrations, or just putting it in a proper space, or will it flow by itself and give it a better finish? You talked about finishing.
Yeah.
To give a better finish.
Yeah.
But will it still need that conventional concrete test or not?
Yeah, we're doing similar, like when we casting concrete field, we usually do run testing called slam testing. So it's like you using a cone and you cast concrete in there and you take it out and you might slide the higher the slam.
The casting part of it, like while you are pouring it or something at that time when the concrete is
Are you talking about the vibration and?
while the pavement is
Yeah, so the higher the workability, the less vibration you're gonna need for your concrete mix. So if you're adding slag in there, as you can see, is because the slag particle is finer and smoother compared to cement particles. So you're getting more paste in your concrete mix typically. So that's why you're having higher slump value, and it's more liquid-like and easier to finish, and you may need less vibration in the whole process.
No more questions? All right. Thank you again.
Thank you.